In this lesson, we are going to start writing down the formulas for compounds and specifically ionic compounds. Before we get into specific types of compounds, we do need to define what a compound literally is and also how to write down these formulas. If you don't know already, a compound is anything that's made up of two or more atoms. This entire time we've been working with singular atoms, so sodium ion was just comprised of one sodium atom, lithium ion is comprised of one lithium atom, etc., etc. Now we're going to start combining atoms to make brand new compounds. So the first rule for writing down compounds is that the quantities for every single atom or each chemical will be written as subscripts, which is simply the text that's written below the regular text. If you recall from writing ionic charges, you would know that your charges are always going to be written as superscripts. So for something like oxygen ion, which has a -2 charge, this is the charge that an oxygen ion has, and it's written as a superscript. To contrast with that, we have our quantities that are going to be written as subscripts. So if you were to take an oxygen molecule, it's O2. What this 2 means, and you can clearly see that it's written slightly below, is that in an oxygen molecule, you have 2 oxygen atoms. And again, it's written as a subscript. So it is very, very important that when you're talking about the charge of an ion, you write it in the superscript position. When you're talking about the amount of an atom, you put it in the subscript position. If you start flipping the positions of these, you will run into problems and you will end up confusing yourself. So try to make sure to stay consistent with where you write your charges and your quantities. Similarly to how charges are written, ones are never explicitly written and are thus implied. So if you only have one of an atom in a compound, that means that you're just not going to write a number under it. This is why something like H2O is written the way it is. So if you were to look at water, H2O, this just means that you have 2 hydrogen atoms and 1 oxygen atom. As you can see, we don't write a 1 under the oxygen, we just imply that it does have a 1 under it. And the last thing is that the final formula will not have any signs of any charges. And this should probably make sense to us because remember, the subscript tells you the quantity of something. A quantity is not going to be charged, and it won't have a positive sign or a negative sign associated with it. It's just a whole number. And it really doesn't make sense to put a sign here, because if you first, for example, wrote H -2O, what you're essentially saying is that you have negative hydrogens, which really doesn't make any sense. You can't have negative hydrogens. You can only have some hydrogens or no hydrogens. This would obviously violate the law of conservation of matter. So make sure that when you are writing things in the subscript position, you never, ever, ever write down any charges. So no positive signs or negative signs should be found in the bottom. That's exclusively for the superscript position. So if we just wanted to look at one example that's already pre-written, we have magnesium chloride. Magnesium chloride is comprised of 1 magnesium and 2 chloride atoms. The reason why you only have 1 magnesium is because the 1 is just implied. So even though there's no number under magnesium, you're technically saying that there's a 1 under it by not writing it down. So in the formula, you have 1 magnesium and 2 chlorides. Make sure that you're comfortable with actually being able to differentiate between how many atoms of each one you have. And now that we have the rules for actually writing down our not our ionic compounds, just the formulas for compounds, we can now get into our first type of compound, which is an ionic bond. Now you should probably be looking at this word ionic bond and have one set of word, or just one word jump out at you, and that's ion. We've seen this word ion before, and we know that there's two types. There are cations and there are anions. And that's exactly what an ionic bond is comprised of. It's a chemical linkage between a metal ion, or a cation, and a non-metal ion, or simply an anion. We've already been referring to it a lot, but we've been consistently saying that metals lose electrons and nonmetals gain electrons. We haven't explicitly decided where those electrons go, however. And now we have a pathway. Whenever a metal loses its electrons, it goes directly to the anion, which is gaining the electrons. So what that means is that this chemical linkage, or this bond, is formed by the transfer of electrons. And this transfer goes in a one-step way. So it goes from the cation, or the metal, to the anion. The cation donates its electrons over to the anion. And remember, when the cation loses the electrons, it will gain a positive charge. When the anion gains electrons, it will have a net negative charge. And again, for the billionth time, an ionic compound is comprised of a cation and an anion, and metals turn into cations by losing electrons, and nonmetals turn into anions by gaining electrons. If you would like to see an example as to what ionic compounds look like, look no further than sodium chloride and magnesium oxide. When looking at both of these, sodium and magnesium, the ones written to the left, are your metals or simply your cations. Meanwhile, when you look at chloride and oxygen, or oxide, you'll see that these are your anions, or nonmetals. Ionic compounds are always going to be written in this structure, where it will be the cation first, followed by the anion. So, now that we know how to write down our formulas and we know what an ionic bond is, we are now ready to name and form ionic compounds. We're going to start with naming our ionic compounds. And the rules for naming are very, very simple. All you do is you take the name of the cation and leave it exactly the same. Then you take the name of the anion, however, you change the suffix of it to "ide." So what that means is, if you are working with an ionic compound like, let's say, sodium chloride, NaCl, which is comprised of sodium and chlorine, the cation is sodium. That name stays exactly the same. The ion of it is known as sodium. The anion, however, is going to have its name changed from chlorine to chloride. So as you can see, I've taken the original name of the anion, chlorine, and I've essentially chopped off that ending and replaced it with IDE, ide. And so when you combine the two together, you end up forming sodium chloride. If you would like to see a diagram as to what this looks like, this is the formation of it. You have sodium atom donating its one electron to chlorine atom. When sodium loses this electron, it gains a positive charge, and when chlorine gains this electron, it gains a negative charge. So you have sodium chloride being formed. It should be quite apparent to everybody, but because these have opposite charges, they are attracted to one another. So the force of attraction that's bringing ionic compounds together, or cations and anions together, is that opposite force of attraction. Now we're just going to go ahead and run through some simple problems with naming. Here are 5 examples. We have CaCl2, BaO, K2S, Li3N, and AlBr3. I'm kind of just going to fly by these, so make sure to just pause the video and practice in your own time. and you should hopefully have paused it, completed it, and we can run through all of these. So here we have CaCl2. First thing to note is that the subscripts for the ionic compounds aren't really going to have a bearing on the name itself. So for ionic compounds, don't worry about these numbers, just let them exist in the formula. So CaCl2 is made up of calcium, which is your cation, and then your anion is chlorine. You're going to change the name of chlorine to chloride. Easy enough. BaO, your cation is going to be barium, Ba, and your anion is oxygen. You're going to change it from oxygen to oxide. Notice how I've only been changing the second element, or the anion. K2S, this is potassium and sulfur. Potassium is your cation, stays exactly the same. And sulfur is going to have its ending changed to sulfide. Li3N, this is simply lithium. Nitrogen has its ending changed to nitride. And AlBr3 is going to be aluminum bromide.